I'm getting a couple of wood 2x4s ready because my 4-foot magnifying lens needs a sturdy frame. I hacked this out of an old TV in a previous video, but it's too flimsy to use on its own. We need something that's super cheap to make, but sturdy and easy to use, and I've got an idea that just might work. Measuring the sides of the lens seems like a good place to start, so let's do that and then mark the wood for custom cutting. It's best to use as little wood as possible, so I'm going to use this table saw to rip these studs in two. This shouldn't compromise the integrity of the frame at all, and it will cut the weight in half. These 2x4s are now 2x2s, and we'll need to cut a groove right down the middle. Once I've got the center lined up, I'll lower the blade down to about 3/4 of an inch and get the saw spinning. As the beam glides over the blade, I'm happy to see that it cuts a clean 3/16 inch groove. This is the groove that our lens will fit into, and sliding the pieces together into place proves that the cuts were good. The edges match up and the frame looks functional, but before we secure it, we'll need to drill some holes right in the center to accommodate this 3-inch bolt. I've added a rubber washer to the bolt and pushed it through the hole, then when this piece goes back in place, we can still access the threads. Oops, I almost forgot. I wanted to add a more finished look to this frame, so I'll add a 1/2-inch chamfer bit to my router and trim the outer edges. I built this router right into my workbench so I'd have a lot of room for bigger projects. Look for how to build this router table in a different project. These simple cuts are quickly giving the frame a more professional look. Okay, those are done, so now I can retract my router bit and lay these support blocks down. The lens goes over top, and these blocks are helping prevent the lens from warping. When we've got one of the corners lined up, we can drill a pilot hole and add a 3-inch wood screw. That's holding well, so let's repeat that on the other 3 corners. Drilling these holes first helps prevent the wood from splitting when the screws go in. The scorcher lens is framed, and we can put that off to the side and get to work on making a collapsible A-frame. This time we'll need to cut 2 5-foot lengths of 2x4 and rip them into 2x2s the same as the others. I want to make a hinged frame, but before we do, let's router these edges as well and save some of the sawdust for a future charcoal making project. Alright, my table is clean again, and I'm going to try an idea for a modified hinge with these eye screws. These screws were $6 for $1 and we'll only need 4. Holes are drilled in the center of the chamfered edge, and then these screws are tightened to where they line up nicely with each other. They stay together closed and fully open, so I'm hopeful this is going to work. It's time to join the A-frame with the scorcher lens. A washer and nut go on the bolt, and now I'm cutting this barbed sprinkler line coupling to act as a spacer. The barb is on with a washer on either end, and the eye screws are added next, followed by a washer, barb, washer, and secured in place with a wing nut. Everything's duplicated on the other side, and these frame legs pivot just the way I was hoping. Next we'll need to measure the distance between the legs and cut 4 more pieces of wood to act as support braces. When those are roughed in place, let's measure about 10 inches from the scorcher frame and make some marks. When we've drilled the holes and added the screws, the frame is pretty much done. The scorcher lens rotates a full 360 degrees and seems relatively sturdy. One more thing I want to try is adding an adjustable tensioner, so I'm cutting a scrap piece of 1/8 inch hardboard into a strip about 2 inches wide and 18 inches long. Then I'll adjust the saw to cut a groove in the center, stopping about 1.5 inches from the ends. A hole is drilled in the frame 10 inches from the top, and the band is connected to the frame with a 3-inch bolt and some wide metal washers. A wing nut will hold that together loosely, then this other end of the strap connects to the side of the pivoting frame about 5 inches from the fulcrum. Oops, that's a little too tight, so I'll back it off a touch and give it a test. I could still rotate the lens nearly 360 degrees, but now I have the benefit of being able to position and tighten this securely at any angle I want. The frame looks great and totally exceeds my expectations for functionality and practical use. The best part is, we made the whole thing custom for about $8. That's it for now. If you like this project, perhaps you'll like some of my others. Check them out at thekingofrandom.com.